I'm Jamie Unwin. I'm a technical architect for the Science Museum's collection, and I'm a co-investigator on the Heritage Connector project, and been working on the technical side of things for Kalyan. You'll meet in a bit. Some of this is going to repeat what John said, but I think we're running behind time, so it's probably quite good. So there's going to be some repetition, but maybe that's good. As John says, this is our collection now. We've got some awfully nice data. The idea is really to move from this work islands to bridging ourselves to the outside world. So two things here. One is actually making the connection within our connection, the extra connections we make there. And then the second one is bridging ourselves to the world. So we're small lines of connected data. And then interlinking that both in our own collection and across Wikipedia and other data. So we've got small lines of connecting interlinked data. And hopefully one of the things we're looking at is actually once you bring that, can we build groupings of stuff? So sort of not only traversing the collections, but can we cluster things together? So if someone's searching for a particular object, we can show things that are sort of in the orbit of that collection. I think John's already gone through this one, so I'll skip this slide. How we do this, so I'm going to sort of dive in technically. Some of this may be old hat and you all know this, and then other people may not. So I thought it'd be worth doing a really quick overview on sort of knowledge graphs and linked data, just so when we get to the demo, you've got a vague idea, or the less technical, got a vague idea what we're talking about. And those of you who already know linked data and SPARQL can go make a cup of tea or whatever. This is a diagram. I'm not going to go into this later. We're basically converting our data from the collection systems into a knowledge graph, and as John said, using a bunch of techniques to extract information and build links on that. I'm going to jump I'm going to do a quick dive into linked data and how we're using it, but we're going to sort of go backwards. I'm going to sort of talk about linked data and what we've created and show you an output of what we've got, and then we're going to kind of see on later about how we're actually been doing that. So we're doing a bit back to front. We thought we'd start with what we've got first. But for that, a quick primer on knowledge graphs and data. As John said, traditional database are very structured. There's boxes for everything. You have to think a lot up front about what you're going to store. So you'd have a people table, a company table, an object table. Linked data is much more, it's about the connections, so that you don't predefine them, which means you can start building these sprawling maps of connections that not only map your own collection, but can then be connected to other systems and then onward connecting, which is great. You build these huge, great big long sort of sprawling graphs of connections. The one downside is you do need to query that. And so on the traditional database, it's kind of, you're much more structured, you know, dealing with linked data. It's slightly more complex to query. It's a different way of querying. We'll come on to that in a minute. But in theory, you can build a knowledge graph as long as sort of sprawling as you like, and then there's techniques to query that. So what is linked data? This can be a really quick primer. So this isn't meant to be exhaustive. This is just a quick, so you can understand what we're talking about later. Linked data is basically, it's one thing. It's called a triple, and all knowledge can be expressed with these three things. So if you have a subject, so it's an object, say, or a person on the left, it can be anything. It could be a statement on the left and a statement on the right, which is known as subject and object. And in the middle, we have something called a predicate. So Jane's father is Bob, or Charles Babbage invented the difference engine. And so if you can state every sort of fact of knowledge in those three things, you can basically chain these together. And that, in effect, is your knowledge graph. So if you're kind of coming back to there, these are all just one thing connects to another. So there's all just, everything there is three pieces of information. So you can kind of see why that sort of linked data approach becomes really powerful in terms of expressing knowledge, hence the term knowledge graph. So you can express things like Bob is a person. That's kind of great in terms of talking about it, but then you need computers to read that stuff. And we know we talk about the same things when we are talking to different people. So for computers, we turn those in, we tend to turn those into URLs. So on the left is Bob, it's a web page, it's our collection web page, it's Wikidata entry. On the right, again, it's a web page or Wikidata entry. it can be anything, anything that can be expressed on the web can be the left and the right hand sides. And in the middle for the predicates, we tend to use predefined lists of predicates. So these are, again, a reference by URLs. Actually, there's nothing special about that bit in the middle. It is just a list of verbs or predicates that say that are agreed upon, sort of loosely agreed upon, and that the more people use certain ones, the more it becomes easier to interrogate them. So things like titles or no's are kind of common ones. You can also create your own ones in the middle, and we do this a little bit on the Heritage Connector. The problem is if you create your own ones, then no one else knows what those are. So it's a bit like grammar with sort of traditional grammar, that you have a language, you're saying thing on the left points to thing on the right. If you use known verbs, people can understand you. If you don't use known verbs and you create your own, you might have to explain to people what those verbs are and how they're used, which then lets you build up graphs like this. So how is Bob related to or Bob is interested in the Mona Lisa. A date is connected to Bob, which is his birthday. Bob's a person, he knows Alice. So you can sort of basically build these up as building blocks, which then lets you build up more bigger connections like this, and eventually allows you to build up things like this, which is more than, I mean, if our Science Museum collection may be a little one of these circles, and then there's a whole world of things that we can connect to. So we're no longer limited to just being able to query our own data, but basically traverse those connections across the whole of the web. John said we're using computational techniques to turn information held in free text into well-identified URLs and RDF triples. So, well, we're doing two things. One is actually for the actual place, objects and people we can try and connect, and then inside those records themselves, we're trying to find the text as well. So we're doing it at two levels, both at the record level and then within the text itself, to try and build those onwards connections. But as John said, this is sort of, we're trying to do this at scale. So we're making errors with this. It's not a hand cranked approach, but we're kind of interested in what happens when you can create links at scale. Can we then use humans? Can we use crowdsourcing? Can we use techniques to kind of hone and improve that linkaging? So we're starting from the kind of sort of go big and bring it back down, rather than just kind of hand cranking these by hand, which is very time consuming. Neither approach is right or wrong. It's just we're interested in looking at it from the other angle. Once you've got that knowledge graph, then it's a question of how to use it. And there's sort of a lot of people built knowledge graphs, and they're already out there. You can sort of traverse Wikidata, you can traverse lots of websites, but you need a language to actually interrogate that. The language that you use to interrogate linked data on knowledge graphs is called SPARQL. You can think of it, if you're familiar with SQL, it's SQL for linked data. It actually has a very similar form to SQL. You sort of a select statement, select things where something equals something. Where it gets interesting is you can actually query across multiple databases. So this is something, on the whole, you can't do SPARQL. SPARQL would be, you'd be interrogating your own collection systems. You wouldn't be able to run a query across multiple collection systems or multiple pieces of knowledge out there on the web. So the really powerful thing about SPARQL is you can query not only your own data, but also all the other data points out on the web. So you basically can query sort of human knowledge of the user. And these are known as federated queries. So I mean, this is an example of federated query. On the left-hand side, we're doing a query within our own database for people, and then we can look to see, do those people exist on Wikidata? And that could be anything, any other Wikidata service, or any other SPARQL linked data service we could do this with. So that means we can start running queries that aren't limited to our own collection, but can be moved out. So some of this is, if you're all deep in linked data, but I thought what we're going to come into next is to give them that as an overview of what we're showing you next. So I think let's jump in. So later on, we're going to talk about how we've been building these connections, but we thought it'd be worth starting with the endpoint of where we've got to, and then you see how some of these, well, sort of see how our data and how we can interrogate the data to have that sort of powerfulness. Don't get too bogged down if you're kind of not following along. We're going to try and sort of explain what these do, but we're not expecting you to know all the detailed technical terms. It's more that you should hope be able to see how we can interrogate this data. And then later in the project, the plan is to actually interrogate the data and then visualize it so you can actually see what we're pulling out. But for now, it's sort of, you might have to make a little leap of faith into kind of imagine that some of these queries can be represented visually, or we can do things with them. I'm going to hand over to Kalyan to shut this. We've got a SPARQL demo. I think I'm going to hand over you, Kalyan, because you're probably best if we've got questions and people want to edit them. So I'm going to stop sharing. Kalyan's going to take over the sharing. As we go along this, if anyone's got questions, do feel free to. We're going to let you have a little play of this demo. We've got a live demo, so we can let you have a play at the end of the session. But if you have got some questions, don't feel free to post it. I mean, we're not able to answer everyone's questions, but have a think about which things you'd like to be able to query and where's we're taking you through this, because that might be useful to later on. We can probably spend some time trying to create some queries for you to do certain things, but obviously we're not going to be able to do everyone's favorite queries, but this will give you an idea of where you can go with it. So Kalyan, do you want to start sharing the demo there?
Yep, thanks, Jamie. Yeah, hi everyone, I'm Kalyan. I am the developer on the Heritage Connector project. Can everyone see something with some SPARQL on it? Cool, amazing. So I'll send this link round after we've got a couple of demos, and I'll send both round, and there'll be time for you to play with them. What you see when you go onto the link is a web page that looks like this. This box will probably be empty. So what you can do here is Wikidata add a query URI that looks very similar to this, which you might have seen. We've got a query library with a few sample queries in. So Sarah, just run this one. So you can go to the query library, click any of these, they'll load the text of the query into here. And then if you either press execute or command enter or control enter, it will run the query. So these are examples of some triples that Jamie was talking about before, some knowledge graph triples.
So let's go back to the top there, Kalyan, just showing that query, because that sort of, in a way, this is sort of saying, we're saying this is about as simple as you can get in SPARQL. It's saying select everything where, and the SP&O referred to the subject, predicate, and objects. And we're only showing you 100 here because we've got thousands and hundreds of thousands. But it's kind of, so you got the SP&O there. So these are all the three things that, those three things that are chained together. So any of these facts, if the left-hand side matches the right-hand side, you can build a chain and chain them together. So okay, you can go on.
Yeah, no worries. So that's the kind of simplest query that it's, well, arguably possible to run in SPARQL. If we look at, so I've kind of pre-populated some in here to give you an idea of what you can do. The ones labeled Wikidata, they're examples of federated queries. So these prefixes just say, whenever I use a prefix, essentially, instead of having to write out all this and then this, you can just substitute in the prefix. I've tried to put comments somewhere, so you can go in, you can run this query. So what this query does is says, get me everything that has top concept, which is kind of what we use in the graph to denote whether it's a person, object, or organization, or in the future also archival document, or maybe anything else we put in there. That has a same as link to a Wikidata item. So these same as links were generated both by mining the collection data for existing URLs and checking that if the URLs pointed to a Wikipedia item or any item that could be resolved to Wikidata, it was actually the same as the record in question. And some of them were created using machine learning. So this might be an interesting one to go explore, because some of these will, due to the kind of properties of machine learning, be wrong.
Is it worth explaining what the WD item is there, Kalyan?
Yeah, so it says items have a same as to WD items. So if the items is every person in the Science Museum collection, the WD item is every Wikidata item that's linked to the Science Museum item. And then what we do is, as an example here, so anything, as Jamie said, inside this service query.wikidata.org tag, what we're actually doing is using this list of Wikidata items which we have in the Heritage Connector knowledge graph and pulling some data, in this case just English language labels of the Wikidata items back from Wikidata. So you can see here is some Maurice Wilkes in our collection, and here is hopefully the same. Yep, there you go, the same Maurice Wilkes in Wikidata with a lot more metadata than we have. So
it's probably worth saying now, I mean, Kalyan's just showing one of the really powerful things there is that on that Wikidata item on the left, we've now got access to all of that data and all the onward connections from that. So that's where we've gone from this really small Maurice Wilkes now collection with no onward links. By connecting up to Wikidata, we've now got access to all of Maurice Wilkes data on Wikidata, and in fact, anything on Wikidata that links to another knowledge graph as well. And by increasing this query, we can keep adding to that. So that means on our collection site or any other service or a third-party service can start chaining those together and build up a much bigger picture of some Maurice Wilkes.
Yeah, exactly. So yeah, the political party membership is an example of actually bringing back some of that metadata. So I think this one might take a while, but essentially all we've added is a line, well, a couple lines saying, get me back the political party, which is denoted by Wikidata P102 member of political party. So some examples here. And then when this runs, it's an example of bringing back some metadata. So yeah, some things you might want to do. I'll move on to describing, see if this runs, name density recognition and entity linking in a minute. So some of these, because they're add-on optional, yeah, it's in an optional block. So everyone's come back, and then the people with Wikidata values of the member of political party property, they've come back with their political party memberships. So yeah, one easy one to get started when I put the link in the Google Doc will be go to get people, organizations, objects with a link to Wikidata. And then here I've written a comment that says you can change person to object or organization. So you can see the kind of quality and the kind of things we've been able to match up. Spoiler alert, it's slightly worse for objects because the concept of an identity relation between two objects is slightly fuzzier than saying this person's the same as this person.
Is it worth showing the political party how you can change the how we can change the property on that one as well?
Yeah, okay, so let me just go into, so to political party membership, ignore that these are called political party, it doesn't matter, they're just variable names. The only thing that you need to change is this here. So this P102 is a Wikidata property. So if I go to anyone's page, they'll have loads and loads of claims which are properties and their values. So let's say we want a member of, so if we click on member of, we'll see a description of it. Any membership of an organization, club or musical group to which the subject belongs. So if I copy and paste this PID into here, what we'll hopefully get under the incorrect heading of political party is their membership to something that isn't a political party. And yeah, this one takes a while.
But that might be a fun one to play with, because you can then start, yeah, you can sit on the right.
Yeah, so you can see So yeah, hopefully you can imagine a world in which you do the reverse query and you're able to look up all the people, say in the Royal Society of Arts and Sciences in Gothenburg, who were past members, who exist in the museum's collection or the collections of multiple museums, without that metadata actually having existed within the collections to begin with, because we don't hold stuff like this. Cool.
I mean, just say we're trying to build on the Heritage Connection, some tools to let you do this without diving into the SQL of the SPARQL. But at this point, we kind of thought it'd be useful. We haven't built those interfaces, so we thought it'd be useful to show what's under the bonnet. And so, if you can imagine that this is what would power a front end. I mean, if you want to write the SPARQL, you can write the SPARQL yourself. But we want to show how that really it's infinitely flexible, rather than just showing you some demos of a couple of outputs. That the Heritage Connection isn't about doing one thing, it's about letting us do these kinds of queries across our collection.
Cool. Shall we move on to name density recognition and entity linking? And Jamie, if you wouldn't mind jumping in the chat, and I think we might have had a few more questions.
Yeah.
And then we will hand you over the links to these demos and hope they don't break. So yeah, John did a really good job of introducing why we're using name density recognition and entity linking, and I have some of the same slides, so this will be quick. So yeah, Jamie showed this diagram quickly earlier. Here's our knowledge graph. This is the software that we're developing. So the query UI queries the knowledge graph. This is collections data from a collections management system, which is ingested into knowledge graph with a few other kind of things to, if you don't use controlled vocabularies, be able to kind of prompt you to use linked open data controlled vocabularies for certain fields here. This record linkage part is the machine learning model to create links with confidences, identity links between collection items and Wikidata items. And then this bit called information extraction with the star next to it is all about creating metadata from text within the collection that we can then add back into the collection as new knowledge graph connections. So I think John used this example there as well. So here is the so-called spacesuit as worn by Helen Sharman. Very little metadata. Helen Sharman's actually down here in related people. Lots and lots of text data with, say, who made it, what the mission it was used on, when it was used, who wore it, etc. So what we can do, as John showed, is run name density recognition and get a bunch of text labels of name densities. So name densities in this case are kind of anything that might have a proper noun assigned to it, with the exception of cardinals, numbers, and dates. And then what we can do is take, so in a knowledge graph, actually just having Helen Sharman as an entity that's been identified in text is a bit, yeah, it will introduce inconsistencies pretty fast, especially when you don't have too diverse a collection. So you kind of increase the likelihood for duplicated names. So it's important to have a step where you actually look at each of these and you say, can I link this up to an entity within a knowledge base? In our case, either the Science Museum Group collection or Wikidata, to identify what entity this or this is actually referring to. So that's when we use entity linking. So you can see that we can identify that Helen Sharman is Helen Sharman in the Science Museum Group collection. We don't hold entities for any of these other, well, apart from this yeah, we don't hold records for any of these entities, but Wikidata does, so we can link to Wikidata. So a quick 3 steps of how it works to kind of let you have a conceptual model of what's going on before I show you the demo. 3 steps. First step is mention detection. So we used Spacey, which is a really common natural language processing library with a couple of additions, extensions to make introducing a new catalog to it really easy without having to label loads of data to do mention detection. So in this example, Anna Atkins has been labeled as a person correctly. There were other things labeled in here for the purpose of this slide. I just removed them. Second step is candidate generation. So given that we have Anna Atkins, predicted type person, the candidate generation step, all that it does is goes and does a search against a knowledge base. So in this case, the Science Museum group collection for this example, and gets back a bunch of, this is exactly just, well, more or less exactly the same as if you just put Anna Atkins into the search page on the Science Museum website, collection website. So you get back a bunch of candidates. And then the third step is candidate ranking. So this is where the machine learning, thus the uncertainties, comes in. So we've trained a machine learning model to look at Anna Atkins, the context that Anna Atkins was mentioned in the original description, and then look at the titles of each of the records that are returned, their types and their contexts. So their context in this case being their descriptions, and give each, but yeah, basically rank these. So we can see that, I mean, I made these numbers up, but they're more or less right. 92% Anna Atkins is the correct one. And then we can set a threshold. So that's something that we'll let you explore in the demo. We can set a threshold and say, we'll only take anything above this threshold because humans have set that threshold, and we can say that everything above that threshold is sort of right. And then if we want to, one of our research questions is looking at, can we do kind of more advanced things with those confidence levels rather than just say, let's accept everything over a 50% threshold. So given that, let's move on to the second demo. So I'll put this link in the Google Doc as well. What you'll get is, I'll give you a website. You will get to a page that looks like this. What you can do is, if you have a particular interest in certain subsets of the collection, you can choose one, energy. And then if you have a even more specific interest, you can choose a subset of that. You don't have to, it doesn't really matter. But let's choose nuclear physics. And then what you see is, so I can use this to kind of go up and down, scroll through collection items. This is the result of the name density recognition model we're using. And then for every entity that is either a person, organization, or object, because those are what we store in the Science Museum collection, you'll see, so this is Butler person, which has been identified here, and then all the linked candidates. And what you can do is adjust the confidence threshold to say, bring back more things in. So we can see that Edward Butler for this was predicted very low confidence, 14%.